Administrator for Exploration Systems Development Mission Directorate at NASA Headquarters. Randy Likens, Vice President and General Manager of NASA Enterprise Solutions at Jacobs. Jeff Zadi, RS-25 Program Director from Aerojet Rocketdyne. Jennifer Bolin Masterson, Director of Operations at Michoud Assembly Facility with Boeing. Doug Hurley, Senior Director of Business Development with Northrop Grumman. Kelly DeFazio, Director of Orion Operations with Lockheed Martin. And Ralph Zimmerman, Head of Moon Programs and Orion European Service Module with Airbus. After a few opening comments from each of our speakers, we'll take questions from reporters here in the room as well as those on the phone. For those listening on the phone, you can enter *1 on your phone to be entered into the question queue. So we'll start with Jim Free.
Thanks, Catherine. Well, good morning, everyone, and it's really great to be here with our critical partners that have worked hand in hand with us to be here today, to have that vehicle on the pad that you see there and really be in a great place to head to launch. And this first launch is another step on the blueprint of our sustainable exploration of the solar system. And we are so proud to be the leader with NASA, with our partners, both within the U.S. and externally. That leadership and that international collaboration comes through our Artemis Accords, and as you saw in the vehicle there, the European Service Module at the top. A lot of questions about what are we doing differently. This time we're going sustainably. We want to stay on the lunar surface and learn on the lunar surface so that we can get the most science and know how we're going to go to Mars. I talk about science. Science is first in what we're doing. On Apollo, we did incredible science at the equator. This time we're going to the South Pole. There's much to learn at the South Pole, and it is truly our focal point. And this is our exploration system. I hope that everyone takes some pride nationally for what we've been able to do and where we are today. That's not been without difficulty, but today we're here to talk about the successes we've had of getting to the pad and developing this hardware for our long-term exploration program. And we are a hardware-rich program. That does not happen in NASA all that often. Just a few miles from here, we have the Orion crew module for Artemis 2. We have the crew module for 3. You'll hear about the development going on those, on the core stage for future missions, on the advanced programs we have. So hardware rich is a great place to be. Artemis 1 is that first step down this path. When we talk about sustained exploration on the lunar surface and getting onto Mars, Artemis 1 is that step. And the countdown starts tomorrow, which is incredibly hard to believe. I feel like I just sat here the other night after the FRR, and here we are starting the countdown tomorrow. Our next step beyond this is Artemis 2. We're putting crew on Artemis 2, and we're exercising the systems on 1 to a great extent to make sure that when we put crew on 2, the vehicle, everything that you see here, a longer duration mission, more time in lunar orbit. Every minute we spend, we learn about the vehicle and buy down the risk for crew on 2. Artemis 3, we're right on the precipice of that as well, where we're going to land the first woman and the first person of color in this Artemis program. That is vehicles coming together today too. Our human lander is being developed. I talked about the crew module, the surface suits that we'll need. All of that is coming together. Again, a hardware-rich and near-term program. And Artemis 4, where we fly to Gateway, and we're orbiting around the moon and landing from Gateway, again, expanding our international partnership. And this is the group that really makes it happen here. It's so great to see the U.S. companies represented and our Airbus partner here as well. So with that, let me turn it over to Randy Likens from Jacobs to hear about everything they've done on exploration ground systems.
Thank you, Jim. Well, good morning. It's great to see you all. Today we're going to talk about the progress that we've made on future Artemis missions. But before we get into that future work, I want to take just a minute and recognize the milestone that we're coming up on Monday. The NASA Kennedy Space Center Exploration Ground Systems team and the Jacobs contractor workforce have done an amazing job assembling and integrating and prepping this vehicle for launch. This new deep space exploration system is going to take us back to the moon and to new science discoveries that we can't even imagine yet. NASA is about to make history with this first flight of the Artemis program, and Jacobs is proud to be part of the team. Artemis 1 is going to prove the capability of the SLS and Orion and Exploration Ground Systems architecture and test the vehicle to ensure that we can safely carry crew on Artemis 2 and then return to the moon on Artemis 3. Here at Kennedy Space Center, the Exploration Ground Systems team is busy upgrading the systems and infrastructure needed to process future Artemis missions. So let's go ahead and start that out. If we could put up our first slide, please. We'll go to the pad. Launch Complex 39, Pad B, is where we're going to be launching from. And this is a photograph of the liquid hydrogen tank. There's been some major upgrades at the pad. The first thing you'll see is the Sphere liquid hydrogen tank. That is the largest tank for liquid hydrogen that's ever been constructed. Holds 1.4 million gallons of liquid hydrogen. And it's going to give NASA the flexibility to have multiple launch attempts in the future as we go forward. Let's also talk about upgrades to the environmental control system. We have to provide conditioned air and gaseous nitrogen to the vehicle, both Orion and SLS, as we prepare and go through the countdown. So those support systems to do that are in. The crew emergency, but we will on Artemis 2 and future missions as we carry crew. So our emergency escape system or egress system is under construction. Let's go ahead and go on to the mobile launcher then and the VAB, which is another major portion of the ground systems here at Kennedy. The mobile launcher that you see there, I think on your right, is Mobile Launcher 1. That is configured for the Block 1 configuration of the vehicle. That mobile launcher will be used for the first 3 Artemis missions. That ML is getting the emergency egress system installed on it as soon as we get back from launching Artemis 1. We've got 15 additional ground systems that are going upgrades and modifications to prepare for the crew version of the vehicle and future growth versions of SLS. The second mobile launcher, which is not pictured there, is currently in design and construction under a separate contract. Let's go on and talk about the VAB. Within the VAB itself, the assembly building, High Bay 3 is where we're constructing, stacking, integrating the launch vehicle and the spacecraft. And we're going to be making upgrades there to prepare for future missions. The environmental control system is under construction for future missions to accommodate the crew requirements. We've also got fabrication of new platforms that are going to be happening to accommodate the Block 1B with the exploration upper stage as we evolve this vehicle and give it new capabilities. High Bay 4 within the VAB is also going to be upgraded to accommodate the EUS processing itself. That's a large upper stage, and it's going to have some special requirements. In addition to the hardware, we also have the launch control software that we're responsible for. So even as we are executing the Artemis 1 launch campaign, we're also working in parallel on the advanced versions of the ground control software, which will handle the countdown and then the launch process itself for the crewed versions of the vehicle. So that software is already 50% complete. We've hit that milestone. We're going to be using that early next year for ground systems testing, and that will be ready in time to support the Artemis 2 launch in 2024. We've also got some modifications going on within the landing and recovery world. After this 42-day mission, when the Orion capsule splashes down, we'll be recovering that, and so we're getting ready for that and preparing to be able to recover crew on future versions as well. I've talked a lot about hardware. Let me talk about people for just a minute. Artemis 2, the next mission in this campaign, is going to be another first with upgraded flight hardware, modified ground systems, and next-generation software. But the key to making this all work together is the people. And the ground ops team has really earned its spurs through the Artemis 1 campaign. The wet dress rehearsals that we've had have been a fabulous learning experience, and the team has executed more than 30 countdown simulations as they get ready for the challenge of launching Artemis 1. So my bottom line is that we're moving out with the upgrades and the modifications required to begin processing flight hardware for subsequent missions. And the plans, designs, and construction of upgrades needed for Artemis 2, 3, and 4 are in the pipeline as well. So thank you very much. And next up will be Jeff Zoddy from Aerojet Rocketdyne.
All right. Thank you, Randy. Let me first start by saying we're very excited about Monday's launch, and we see this as a generational rocket. And Aerojet Rocketdyne is doing everything that we can to make it a big success. So if we can go to the first image, as you may know, we're reusing 16 Space Shuttle main engines to support the first 4 Artemis missions. Now, we're adapting those engines with new engine controllers. That's the brain of the engine. We're also adding a thermal protection system to the nozzles, and we're upgrading the software. The image you see is of the work platform at Aerojet Rocketdyne's engine assembly facility at Stennis Space Center, where the work is being performed. And I'm happy to say that that work is well ahead of schedule. Artemis 2 engines are complete and ready to ship. 3 of the 4 Artemis 3 engines are ready, and the 4th is nearly complete. And we've even started to assemble 2 of the Artemis 4 engines. So if we go to the next image, you'll see a photo of our RS-25 certification engine, which is also being assembled at Stennis Space Center. Now, we are restarting production after a 15-year gap. And while we're maintaining the safety and the reliability of the RS-25 engine, we're also introducing targeted redesigns to reduce cost. Those changes need to be certified. And so the assembly of our certification engine is 90% complete. That engine is going to start testing later this year, and it'll continue testing through the middle of 2023. And if we can go to the last image, this is a picture of our nozzle braze furnace located in our Canoga Park facility in California. This is the largest furnace in the country. Aerojet Rocketdyne has invested to increase the capacity in our Canoga facility. We are also modernizing our manufacturing techniques, including using 3D printing. We've got 39 components that are 3D printed. That means reduced part count, reduced touch labor, and reduced cycle time. We're also ramping up production. We've got components in work through Artemis 9. And so the combination of targeted redesigns, modern manufacturing techniques, and a ramp up in production is enabling us to reduce the cost of our new engines by 30%. So now let me turn it over to Jennifer.
Thank you. Good morning, everyone. I'm excited to talk a little bit about our future. And so let's go to the next slide. The first 3 Artemis will be the SLS Block 1. Artemis 4 is evolving into our Exploration Upper Stage, EUS, Block 1B. This will enable sustainable and scientific rich explorations for the SLS missions. This is why EUS and Block 1B is so important. EUS is going to be able to provide 97,000 pounds of thrust versus the Block 1 at 25,000. So what does that mean? It means it's 3 times the amount of lift power to get us to the moon and beyond. It also provides 40% more payloads, or 38 metric tons, or 83,000 pounds. SLS with EUS provides payloads that co-manifest with the Orion capabilities. Potential missions that launch on SLS and with EUS can include large Earth observation satellites. It can include space telescopes, and it can also include missions to our outer planets and their moon. Next, please. Boeing is and has been committed into improving our production and manufacturing processes by utilizing lean principles. We have taken our core stage 1 and core stage 2, our lessons learned, and have applied them to our EUS exploration upper stage before we even start production. A couple examples of that is with our design of our tools. We are utilizing some of the same tools that produce core stage. We're producing EUS right off of the same thing. We've also improved our design and process improvements. When we talk about the installation and the testing of our wire harnesses, we have seen improvement, and we have applied those to our EUS. And along with utilizing friction stir welding, not only does that provide us weight improvements for our article, but it also improves our quality and our schedule. In our factory today, we are producing the weld confidence articles along with our structural test articles for EUS, and core stage 4 is in the production build also. So it's exciting times today, but also for our future. With that, I will turn it over to Doug Hurley with Northrop Grumman.
Thank you. We're L -3. It's just an exciting time. I can't wait to see that thing launch on Monday morning. Hope everybody can make it out and bring your families as well. Certainly, from my perspective and Northrop Grumman's perspective, we've had a wonderful heritage with the solid rocket boosters, supporting shuttle. And we're fortunate enough to have 8 flight sets to support Artemis 1 through 8 with our heritage shuttle boosters. Now, we've improved them as far as adding a segment. So we've improved the thrust by 25%, and we continue to optimize our design as we fly out that hardware from our Booster Obsolescence and Life Extension Program, or BOLE. I don't want to use too many terms, but that's our Artemis 9 boosters and beyond, where we can go to that slide, please, where we go to a composite case and do significant improvements, as you can see, including structure and propellant materials. We've got an electronic thrust vector control that we're going to be using, as well as some nozzle throat expansion. And it gives Artemis SLS the capability of roughly 5 metric tons of additional capability. So it's really, really impressive. So we're already hard at work at that, and you can see some of the other things we're doing as far as increasing our burn times. We're doing some other optimization along the way and really tweaking the design to take Artemis to that next step. Next slide, please. You can see here, this is a case winding for our DM1 test motor. So this will be our first BOLE test motor that we fire. We're targeting 2024 at this time. We're also doing some other work with Marshall Space Flight Center. You can see in the upper right corner there is a subscale motor test, and we've done 3 of those with a 24-inch solid rocket booster. So we're working very hard to support Artemis 1 through 8 with our current shuttle hardware, and then we're looking very much forward to flying our new boosters on Artemis 9. Thank you. I'll turn it over to Kelly now for a little bit of Lockheed Martin.
All right, thanks, Doug. Like my colleagues, the team at Lockheed Martin are totally energized to be here just days away from the Artemis 1 test flight, because that test is going to give us the information and the data we need to prove out our systems and make Artemis 2 successful as well. So if you go to the first image, you can see the Artemis 2 crew module is well on its way in fabrication in the operations and checkout facility here at Kennedy Space Center. We did the initial power-on activities earlier this year, and it is going through its test phase and will roll into the integration of the other components for Artemis 2 and deliver into NASA's hands in 2024. In addition to Artemis 2, we have Artemis 3's crew module also in the ONC facility, and it is going through its primary and secondary structural installation, and later this year will go into the clean room for welding activities to install the propulsion system as well as the ECLSS systems. Artemis 4 also in work. Artemis 4's crew module, the pressure vessel, is being fabricated at our Michoud assembly facility with our Lockheed Martin team there, also using the friction stir weld for optimizing that pressure vessel. And it will be delivered here early next year, about the February timeframe. And that's going to put us exactly where we need to be here at Kennedy Space Center with 3 spacecraft in flow at once. It's that rate that we need to be ramped up to meet the 1/1, the mission over mission annual rate for NASA, and we are on plan to meet that. Artemis 5 also being built. Artemis 5 is across our 2,900 suppliers in all 50 states, including Puerto Rico, as well as 11 countries. And that Artemis 5 hardware is being built as we speak and will be rolling into its integration facilities as we move into the next few years. So Lockheed Martin is committed to reduce the Orion production contract to deliver spacecraft 50% cheaper than we were from the early stages of the flight hardware. And a couple of the ways that we're doing this is not only the economies of scale that we just talked about, the bulk buy, capitalizing on bulk buys, but we're also creating infrastructure and production efficiencies and using digital transformation and state-of-the-art tooling with augmented reality, as well as flight hardware reuse. The flight hardware reuse is critical to Orion spacecraft cost reduction. We actually have on this mission, Artemis 1, we have used a flight battery from our EFT-1 mission, our test flight in 2014. We've taken a flight battery from that, we've repurposed it, and it is actually sitting on board Artemis 1, as well as a couple of harnesses from our test phase of EFT-1. From Artemis 1 to Artemis 2, we will take 16 components. Most of those are high-dollar avionics. One is the crew seat that Commander Munikin Campos is sitting in, will be repurposed and become part of Artemis 2. And then, as in a usual engineering phased approach, we're going to ramp up that number for reuse. From Artemis 2 through to 5, we're going to be in the realm of about 600 reusable parts. And then from Artemis 3 to 6, upwards of 5,000 parts. So we are ramping up quickly, and our team is working hard to qualify all of that for multiple use. Some of them are on 5 missions, some of them are 2 missions. And as we gain this information and data from this test flight and Artemis 2, we might be able to increase from there. If you go to the next chart, this shows a couple of our mechanics and technicians using augmented reality. On the left is the crew seat assembly at our Michoud assembly factory using HoloLens goggles. And on the right, we have a mechanic at the O&C facility, and she's placing click-ons on flight bracketry there using the HoloLens. So if you can imagine, you know, a HoloLens augmented reality, it's not quite like your virtual gaming goggles at home where the whole world is blocked out. You can actually see the hardware and the people in front of you, because you certainly don't want to run over anybody while you're doing this. So you can see the external environment around, you can see the hardware you're working on, but overlaid on top of that, you can either see the CAD models, you can see the instructions. The instructions are in the field of view, tells you what you need to do with the hardware you're looking at, what tool to use, and all of the features. So imagine no more manual double checking. What did that instruction say? Let me walk here, let me walk over there. There's also an added feature where when you start to combine these tools together, we've seen upwards of a 30% cost reduction to the mechanic and the productions on the floor, 300% a reduction. So this is just a couple of examples of how we are using that particular augmented reality. In addition to that and other digital transformation projects with smart tools, we are also incorporating the 3D additive manufacturing in our flight hardware and driving the cost down. So Lockheed Martin and our Orion partners are committed to this. And again, we are extremely excited to be a part of the NASA manifest and the architecture to go to deep space and beyond. And with that, I'm going to turn it over to Ralph Zimmerman for Airbus and Service Module.
Thank you very much, Kelly. Yes, let me just continue where my partners already stopped. I'm very excited to be here. All Airbus is very excited to be part of the team. And I guess it's a great mission, and it's the first time ever in history of NASA, the NASA trusts a basically non-US company to contribute to a major program in NASA. And I guess, let me expand a bit why we think we deserve this kind of trust. Airbus has quite a heritage in space systems. We have already built and delivered the Space Lab. We have built for the ISS, the Columbus module, and even more than that, we have built the automated transfer vehicle and delivered 5 of those vehicles which automatically provided goods, fuel, and consumables to the space station. And basically what we're building now, the European Service Module, is a derivative which is based on all the knowledge which we have gained in the automatic transfer vehicle. And as such, I guess the trust is there. We can come to the first picture, please. We have, I basically put some people in front because we were very excited that NASA and all the top guns of NASA were visiting us. Thank you, Bill, for coming. This was really great. It was a great inspiration for all our team, but it showed also that NASA is willing to trust the European partners. And for me, and I have quite a history in space business, international cooperation is quite key if you want to go to moon and even beyond. So in this sense, I'd say the cooperation is great. We have an excellent interface with Lockheed Martin, with our agencies in between, with NASA and ESA, and as such, a great team can move a mountain. And this time we don't want to move a mountain, but we want to fly around the moon. Cool. So let me give some words towards what we are building. Go to the next slide, please. This is just a sketch of the not fully equipped European service module. It is quite densely packed, I might say, and this is not yet even full. So all the tanks are yet missing. So we have more than 20,000 piece parts to integrate in this diameter of a bit more than 4 meters and height of also a bit more than around 5 meters. We integrate quite a lot. We have more than 8 tons of propellant. We provide later with our solar arrays about 11 kilowatts of electric power. We have all the consumables for the astronauts, the oxygen, nitrogen, water. And we take care for the environmental control of the capsule in terms of that we do the cooling and provide the energy for the heating. And as such, I guess the cooperation with inside the Orion team between Lockheed Martin and Airbus providing the service module is working really great. And I'd like to thank all to the colleagues that this works this well. And you can imagine it's not that easy, especially in the last 2 years, which were a bit blocked by personal contacts. We were happy to make this, and now we have delivered not only the first one, which is on the rocket. Actually, we delivered it already 2 years ago, I might say, since then here in testing. The second one is also over here in KSC, being just mated with the crew module currently and tested. Number 3 and 4 are integration in Bremen, north of Germany, in our integration site. And we are under contract for up to number 6. So the structure for number 5 will arrive before Christmas, and for number 6, even before mid of next year. And we are increasing our integration capabilities to handle really 3 ESMs at one time in our facility. And I guess with that, we are prepared to deliver one module per 1 ESM per year and achieve the cadence which we all want to see. And thank you for that. I'm handing back to Catherine.
Thank you. We'll now take questions from reporters here in the room, as well as those joining us on the phone. For those joining on the phone, please press *1 to be entered into the queue. We're also taking questions on social media using the hashtag #AskArtemis, when we go to you, please state your name, your affiliation, and to whom your question is directed. We ask that you please stick to one question so that everyone has a chance to ask a question, and if we have time, we'll come around for another round of questions. All right, so I see a few hands here in the room. Let's go over here on the second row over here. Oh.
Oh, thank you. I'm Mark Carreau with Aviation Week in Space Technology, and I think my question's for Mr. Free. Do you have some estimate of the number of companies globally that have contributed, and even perhaps the number of personnel that work around the world, if not around the world, in the U.S. that are involved in this?
Yeah, so I think Catherine said at the beginning, overall it's been, I think, over 3,000 companies that have participated. I will throw out another number, that 700 small businesses as well. And I think that's tremendous that small businesses play a role in this. I don't have the workforce numbers off the top of my head, though. I think we can follow up with you on that, Mark. I know I saw them yesterday, but if I quote them wrong, I can't look to my right because someone will be a little bit upset with me. So we owe you that, though, Mark.
All right, let's go here to the front row.
Hi, I'm Jim Siegel. I'm with NASATech.net. And I believe my question is probably directed at Jim, although I'm not sure. Maybe the rest of you will chime in. When Artemis was announced a few years ago, I recall that there was an effort to go through Artemis 1, here's Artemis 2, Artemis 3, Artemis, and here's what we do on each one of those. And you've touched on those, but I wondered if you could kind of go through the list, starting with, say, number 2, and what is the goal of each one of those, and what's the time frame for each one of those going out to Artemis 9 or whatever the highest number is? Can you do that, please?
Sure. So just one is our uncrewed test flight, where we're buying down a lot of the risks that are in the system and even flying I'll say a riskier mission with some of the durations we picked. 2 is a crewed flight. So I should say 1 goes into a distant retrograde orbit. 2 is a crewed flight where we'll, again, prove out more systems, the environmental control and life support systems. That will go on a free return trajectory to the moon. Again, buying down the risk so that we don't have to fire to come home. 3 will go into the near rectilinear halo orbit with the human lander and land. 4 will go to Gateway, where it'll be the first flight of the Block 1B vehicle that was mentioned earlier, where we'll take a co-manifested payload, another international payload, and dock that to Gateway. 5 will take another co-manifested payload. It will also bring in the lunar terrain vehicle on the surface. And then when we get 6 and beyond, we start talking about potential airlock. And then 7, we get into a cadence of where we're doing more science. We start to bring in, on the later missions, 7, 8, 9, we bring in a pressurized rover. We start looking at surface habitation. And so that as we're going through our yearly mission, we're maximizing the science. We're also designing things like LTV to be on the surface, and when the crew's not there, to be operated to do science, much like we operate the Mars rovers today. That definition, when we get 6, 7, 8, 9, that's what we're going through right now. Honestly, when you look at the schedule for 4 and all the elements that have to come together, it is a significant emotional event of how all that comes together, because it's like, hey, at that point we're full steam ahead into our missions. So we're at 1 through 5. We're working the details of 6, 7, 8, 9, and 10, and at the same time we're developing our architecture through some of the objectives work that we've done recently through our deputy administrator, going through the broad exploration objectives and then narrowing down to an architecture which takes us out to Mars, and we're looking at rolling through that architecture decisions and process in the early part of next year.
Thank you.
Yes, sir.
Thank you. Did I see another hand? We'll go over here to the second row.
Yes, thank you. Tarek Malik with Space.com, and I believe my question is for Jennifer. I'm curious about the development of the exploration upper stage for that Artemis 4 flight, just because it seems like a fairly large leap with a lot of demands for that mission, and I'm curious about what will the testing regime be? Do you need to fly an uncrewed a test on a different type of a booster just to kind of prove it out before Artemis 4, or
explained a little bit, we're going through our structural weld articles right now, making sure everything looks good there. Our structural test articles will be, again, another way to prove our capability. Now, our EUS 44 will go through to the Stennis Space Center, where we will do a hot fire, very similar to Core Stage 1, where we did a hot fire at Stennis, and then come to the KSC-4 launch. So that is kind of our development plan and how we're going to prove out our capabilities with our EUS.
Thank you. Next, we'll take a question from the phone. We have Andrew Tangle of the Wall Street Journal.
Yes, hi there. How are you? I didn't know if the members of the panel from the industry could maybe outline how profitable this program has been for their companies, and give us a sense of how, as NASA tries to reduce costs for the future missions and shift some of the risk and financial responsibility to the industry, how willing your companies are to accept lower profit margins or even losses on future missions as this goes forward.
So we'll start with Jacobs and then go down the row here.
Okay, sure. As we evolve and work through future missions, we fully expect to see the workforce requirements, for example, changing as we get smarter and we get more experience in processing ground hardware, developing the new systems. The labor required to do any particular operation should absolutely be going down, and we anticipate that on future contracts. I can't really speak to how profitable a particular contract is specifically, but it's in their public domain. It's in the public domain out there, so I'm sure that information can be found. But at any rate, we want this to be a 30-year sustainable program, as NASA has talked about. So we realize we all have a part to save money, to be more efficient as we go forward, to bring in new technology, and I can certainly speak for Jacobs to say that that's our approach.
Yeah, thanks, Randy. From my perspective, Aerojet Rocketdyne, first I would applaud NASA for what they're doing to look for solutions that make producing and operating this vehicle more affordable. What I would expect is, we're excited about this in the future as we see the launch manifest stabilize and we see the launch cadence stabilize to at least 1 launch per year, maybe 2 launches per year. I would expect us to come down those learning curves. And, the continuous improvement, it's a journey that doesn't end. So we're going to always look for opportunities to reduce costs. That's not going to stop.
Yeah, you kind of took the words right out of my mouth there. It is really important for us to continuously innovate and find better ways of processing, designing, all of that to make this affordable. We are here for the long haul. We want this future. And so our teams are consistently, day in and day out, I'm on the shop floor and they're talking about, hey, I have a good idea to make this a better way of producing it, or hey, could we go do this? So, it's really taking our teammates and their innovation ideas and really putting them to the test and getting them implemented. And so we are going to continue to do that day in and day out.
Yeah, I would totally agree. We at Northrop Grumman were committed to a significant reduction in cost as we, responded to the epoch with our partners. We understand that this program needs to be sustained. We understand that, and we're going to do our part in reducing cost and efficiencies wherever we can get. And as I said before, our newer boosters, that's just going to lean things even more. And we are working together. We work very well together with our industry partners, and we're going to continue to do that to make this program successful.
And as mentioned earlier, Lockheed Martin is committed to reducing the cost by 50% in our production run. And, we are on from a design development program, we're on the cost plus award fee contract. We have transitioned to the cost plus incentive fee contract in our production runs and working into the firm fixed price. So that all works together. It's, the way we need to start shifting the risk in the, from the government to the industry and make sure that we are all driving our costs down for that sustainable future, because we absolutely are here for making Artemis a program for decades to come, and that's the way we're going to do it.
Yeah, being the last one in the row leaves little to add of what all my colleagues have already said very rightly. Maybe just something which is worth to note here, because it might not be clear. The European part is financed, so we are under contract with the European Space Agency, and this is based on an agreement from agency to agency, so we are not working on American taxpayers' money. We are working on European taxpayers' money. Maybe this helps to understand.
Thanks. We'll take another question from the phone. Laura Winter of Defense and Aerospace Report.
Good morning, everybody. This is for the primes and also for the NASA reps. Without taking away from your accomplishments in the least, space is a team sport, and you all have mentioned locations around the United States like Stennis and the city of Canoga Park in California. Lots of work also occurred in Ohio, testing at the NASA facility, but there's also lots of additive industries there. Can you share the glory a bit and talk about the small and medium-sized businesses that have and are supporting this launch and the coming missions? Can you give a few examples? Thank you.
Yeah, I went to a supplier event, I forget when, down here a few months ago, and and met some folks that were making a particularly difficult part for SLS, and it was a mechanical part, small mechanical actuator, and it was like this gentleman who started the business from the ground up himself, and he and his wife were down here and kind of swimming in the sea of like, wow, I've never been part of anything like this, and actually got to meet Doug Hurley. They got to meet Doug Hurley, which is a highlight for anybody. But for them, to see their, I'll say their excitement renewed for me the value of what we do, both at the big and small level, and just what we do for inspiration. My other colleagues might have some other small business examples.
Yeah, I would comment on that. In my former career, we spent a lot of time visiting these smaller shops. They contributed to shuttle, and we started doing the same thing as we were turning towards SLS. And I agree. It's amazing. These small companies, they build one part or two parts, but the emphasis on understanding how important those parts are to the overall mission and how they can have either a great effect or an adverse effect. And it's just incredible to just see at those supplier conferences the small companies all around the United States that contribute to this program.
All right. We'll take another question from here in the room. We'll go over here to the second row.
Thank you, Tarek Malik with Space.com for Ralph. I'm curious about Airbus's experience with this service module and building that for like a future vehicles that you may have planned for European crewed flights, things, an evolution of ATV, perhaps. What sort of lessons have you drawn from the service module here that can be applied to future European spacecraft? Thanks.
Well, the service module is, in terms, if you compare it to the automated transfer vehicle, just a part of it, basically, because the automated transfer vehicle also had all the avionics, logistics, onboard computer inside, and a big cargo trunk up front to deliver space goods. Nevertheless, what we learned on top, of course, and what we did is the service module is now completely human-rated. The ATV was only partly human-rated just for the docking phase when it really approached the space station. So by that, we have additional redundancy inside, and of course, we learn a lot with that. And I guess we have learned already previously how we can reliably produce these kind of very complex stages. So, and as such, now we are optimizing, as our colleague said before, in the cost reduction to see what we can do and narrow it down to make sure we have an industrialized production and get out one per year. This is our goal. And we have invested at Airbus to have really 3 in parallel in our clean room facilities. Hope this answers your question.
Thank you. We'll take another question from the phone. We have Marvin Marshall with Nighttime News Space Report.
Hi, my name is Marvin Marshall from the Nighttime News Space Report on Twitch.tv. My question is for Doug Hurley. Doug, it's a pleasure to meet you. Being the first commander on board the SpaceX Falcon 9 rocket and Crew Dragon, I'm sure you've worked very closely with SpaceX, to make that flight happen with Bob. Now, what did working with SpaceX on advancing human exploration by making, Falcon 9 human-rated teach you, and how much confidence did that whole process give you and our ability to return to the moon and lunar surface aboard a SpaceX, Starship and Orion capsule in the coming years with the Artemis program? Thank you.
Hey, Marvin, great question. Yeah, it's a process, right? We had a great team, a relatively small team at NASA that worked with SpaceX, and the collaboration was incredible. And I've seen that. I didn't get to do a ton of work with Orion and SLS just because my last 5 or 6 years at NASA was working with SpaceX and with our NASA team to get us to ISS in 2020. So, but it's a very similar mindset. You have your ups and downs. You work through those processes. People remember we had some pretty significant ups and downs getting to the launch pad with SpaceX. What I like about Artemis 1 and this flight test, this end-to-end flight test, is we're really pushing the hardware on this particular flight to give us that confidence to put crew on it on Artemis 2. And very similar mindset as to what we did with DM1. If you remember, we flew an uncrewed test flight as well. We also flew an in-flight abort test, and then we put crew on Falcon 9 and Dragon. So I really like the direction where we're going from, a former test pilot, and this is a very measured approach, but we're being really aggressive with what we're asking the hardware to do on this particular flight. So we have total confidence when we put our crew on board.
Thank you. We'll take a question from social media.
Hey, thanks so much. I've got a question from Twitter, and I think this one is for Lockheed. What improvements have been made since the navigation systems? What improvements have been made to the navigation system since the Apollo years?
Wow, how long do we have? So, over the last week, I've heard a lot of the information and seen a lot of the facts flying around of the comparison between Apollo and Orion, all the way down to the shape itself, and there's certain things that you just don't need to change and shouldn't change, like the shape, right, for the dynamics, the flight dynamics of the spacecraft. The advances in all of the avionics, the navigation, the guidance, the flight computing is just monumental. I mean, if you can just imagine, back in the 60s, nobody even had a PC. So, I mean, it just when you talk about the flight equipment, it is not even in comparison, down to the power, right? They had fuel cells on Apollo. We have solar cells on Orion, and you can just go down the list and it would take a long time. But I think I remember a fact that said that the computing power, I'll just put it this way, the computing power on Orion is 4,000 times greater than on Apollo. So that just kind of puts it in perspective. And all of our partners are incorporating all the state-of-the-art technology to make that happen as a system. So it is the same in some aspects. Some of the materials are the same, but the computing power and the technology to build this spacecraft, it is the safest spacecraft for humans ever created. For our astronauts, it will go farther than we've ever gone before on Artemis 1. 40,000 miles beyond the moon, and we are super excited to see how it perform. That heat shield on the back end is going to show us how we've taken that material from the Apollo days and brought that into the 21st century from a new way of manufacturing it, as well as larger. The Orion is about 30% larger than the Apollo crew module or capsule as well. So some things are the same. We've built on the past and just made it thousands times better. We're standing on the shoulder of giants, but we're ready to go.
And I think, I saw one more question over here in the, looks like third row.
Hi, my name is Kane Faribault. I'm with Voice of America, and my question is less technical and a little bit more emotional. Certainly, most of you were either little or not even born yet when all of this happened the last time. And if you've got children, they've certainly have never seen this occur in their own lifetimes. And maybe you could each maybe share some of the emotional sort of response it is to be in this moment, you know, close to the launch where this is all going to start again. And you're at the end of a very, you know, long process, but maybe tell us how you feel emotionally right now to be in this moment.
Start here with Jim.
Let's start with Ralph. He keeps having to go last. Let's start with Ralph.
Happy to start with this. You're fully right. This is an extremely emotional moment, and in my career I have launched several spacecraft, so this is not the first one, but certainly one of the most exciting ones. This is no question, yeah. Usually you have a lot of tension. I mean, during the development program, you have problems to solve, you have interfaces to solve, and finally you make it, and then this is the moment when it comes to the countdown, yeah, and then tension starts, and well, let's cross fingers, everything works well, yeah. Tension is rising, and we are fully excited here.
So for me, this is a personally exciting moment for me as well. I was born and raised in Titusville, and my parents came down from Pennsylvania to be a part of the Apollo program, and so I'm the Apollo generation, you know, times one, I guess, X1, and just super excited for me to be here and kicking off the Artemis generation. And to see that in one lifetime is quite incredible. My family, you know, met my husband as part of the aerospace industry. My son's in it now, and my daughter was talking about the other day how they're all coming in to see the launch on Monday, and I asked her, you know, what do you think about this? Because she's not in the industry, but she's certainly seen her dad and I working in it for a lifetime. And she says, you know, I think it's really cool. And she said, I can't wait for my grandkids to tell me, hey, Grandma, we can't come over this weekend. We're going to go vacation on Mars. So do you want us to bring you something? And she's going to say, just bring me a picture. But, you know, I was there on day one. So we're excited as a family. And we've got Lockheed Martin team flying in and driving in from all over the country. And, you know, we're going to have a lot of fun. And we're going to be excited. And we're going to watch every single day of those 42 day of the mission and just, you know, looking forward to that information come flowing in and take all that and go from there. Okay.
You know, it's really mixed for me. You know, I feel so much for the teams having gone through this to a smaller scale for 6 years, trying to get back to space station, and now the amount of time, the amount of people have spent significant parts of their career already to get this rocket to the pad. And I'm just so happy for them and excited for the nation, for the globe to be going back to the moon and then hopefully beyond to Mars in the not too distant future. So it's a little odd for me being on the other side of it, not in quarantine at crew quarters, getting ready to go fly the rocket, but just have ultimate confidence in this team, and you know, looking forward to seeing some of my friends get to fly this rocket in the very near future. So just exciting, and just want to tell everybody, you know, just live in this moment. This is a big deal. Take it all in and enjoy it the next few days. It's going to be fun.
For me personally, you know, a little over 4 years ago is when I joined the program, and so I moved my family to New Orleans at the Michoud Assembly Facility. And, you know, my family got to experience all the challenges. They got to hear from me about all the challenges that we were going through. And so I can't even put words into it of how I feel. It's unbelievable. And I'll tell you, the team out at MAF, their energy level is to the nth degree. You know, I remember when we rolled out on January 8th of 2020, the first core stage going to Stennis, and it was electrifying. And then when we completed hot fire, it was amped up a bit. And then when we got it here and we passed wet dress, again up. Now, everyone is taking it in the moment. You know, we've got lots of teammates coming out this way to watch it. We're making sure for those folks, those teammates that could not make it out here, we've got a watch party at the factory ready for them to go and celebrate the huge accomplishments they've had. You know, we went in through this COVID, you know, 2 years of COVID and trying to get through that obstacle. Anyone that knows Louisiana, the past couple of years we've been hit with hurricane after hurricane after hurricane, and this team, no matter what, with their homes with no power and no running water, still was coming into work and making sure the mission was going to happen. So couldn't be prouder of the team, and the energy is just, you can't even explain it in words.
Yeah, for me, I grew up in South Florida, so I've been around launches, and I was always fired up about that. This experience is extremely gratifying, to know that you're part of, really the start of, something big, something that, historically significant, deep space exploration. And what makes it more significant, more meaningful for me is being able to share the experience with my family, with my wife and our 4 kids. I think they're as excited as I am. And so that's just great to see the excitement.
So I was a young boy laying in the floor watching Neil Armstrong and Buzz Aldrin stepping out on the moon, and I remember rolling over and telling my parents that's what I want to do someday. So that motivated me to go to engineering school, to get 2 degrees, to get into the NASA world just as quickly as I could after graduation. I like to say I wasn't born in Huntsville, but I got there as fast as I could. So, but anyway, this is our Apollo. That's really what it is.
And I'll say on the non-emotional front, our team has to manage their emotions right now. I'll get to emotions in a second, because we have 3 very clear objectives: get the vehicle to orbit, test it, understand how it operates, understand where we need to come home early if something's wrong, and make that decision. We have to get it to orbit and test it. We have to test the heat shield coming back, and we have to recover the vehicle. And we have to balance risk through that whole mission. Every time we make a decision, we commit to go to the moon, we've made a decision that limits how we can come back. We still have options. We might have to decide, do we need to come back? And beneath all of that is this incredible pride that people have in what they've done, in what their families have given up, in what they've given up. People have lost marriages to this program, right? People have given up hobbies that they've had their entire lives because this business is absolutely crazy fun to be in. And so beneath all of that technical, all of those decisions we have to make, the pride and emotion that people have is truly, truly incredible.
I think that's a great note to wrap up on. Jim, anything you want to add for closing remarks?
No, I just want to emphasize that this is the team that has made it happen. I said at the Flight Readiness Review the other day where, there are tremendous people in that room. And I said at the start of it, I said, 99% of the people responsible for getting us there to that Flight Readiness Review were not in the room. And those are the folks that I want to highlight and ask all of these folks on your team to thank them for me personally and thank their families. And that's what this is about, is the people that built it and the people that really have ownership of that. And for me, that's everybody really across the world when you look at this panel, but certainly those folks in the U.S. that helped us get here.
Thanks, and with that, I'd like to thank you all for joining us. You can learn more about the mission by going to nasa.gov/specials/Artemis-Roman numeral 1. That's all lowercase letters. And thank you for joining us.